4th International Physics Olympiad year 1970 IPHO. Problem number 1. A long bar with a mass big M equal 1 kg is placed on a smooth horizontal surface of a table where it can move frictionless. A carriage equipped with a motor can slide along the upper horizontal panel of the bar. The mass of the carriage is small m equal 0.1 kg. The friction coefficient of the carriage is mu equal 0.02. The motor is winging a thread around the shaft at a constant speed v0 equal 0.1 meters per second. The other end of the thread is tied up to a rather distant stationary support in one case, figure A, whereas in the other case it is attached to a picket at the edge of the bar, figure B. While holding the bar fixed, one allows the carriage to start moving at the velocity v0, then the bar is let loose. By the moment the bar is released, the front edge of the carriage is at the distance L from the front edge of the bar. For both cases, find the loss of movement of both the bar and the carriage, and the time during which the carriage will reach the front edge of the bar. 4th International Physics Olympiad year 1970 IPHO. Problem number 2. A unit cell of a crystal of natrium chloride, common salt, is a cube with the edge length A equal 5.6 multiplied by 10 power negative 10 meters. The black circles in the figure stands for the position of natrium atoms, whereas the white ones are chloride atoms. The entire crystal of common salt turns out to be a repetition of such unit cells. The relative atomic mass of natrium is 23, and that of chloride is 35.5. The density of the common salt, ρ, is 2.22 multiplied by 10 power 3 kg per cubic meter. Find the mass of a hydrogen atom. 4th International Physics Olympiad year 1970 IPHO. Problem number 3. Inside a thin-walled metal sphere with radius big R equal 20 centimeters, there is a metal ball with the radius small r equal 10 centimeters, which has a common center with the sphere. The ball is connected with a very long wire to the earth via an opening in the sphere. A charge big Q equal 10 power negative 8 coulomb is placed onto the outside sphere. Calculate the potential of this sphere, electrical capacity of the obtaining system of conducting bodies, and draw out an equivalent electric scheme. Fourth International Physics Olympiad year 1970 IPHO. Problem number 4. A spherical mirror is installed into a telescope. Its lateral diameter is d equal 0.5 meters, and the radius of the curvature r equal 2 meters. In the main focus of the mirror there is an emission receiver in the form of a round disc. The disc is placed perpendicular to the optical axis of the mirror. What should the radius r of the receiver be so that it could receive the entire flux of the emission reflected by the mirror? How would the receiver flux of the emission decrease if the detector's dimensions decreased by 8 times? Directions. When calculating small values, square root from 1 minus alpha approximately equal 1 minus alpha over 2.